global hypersonic technology race is on fire, with world powers fiercely competing to surpass the speed barrier. While the fastest aircraft today achieves a speed of 500 km or 75 miles per hour, China has unveiled a technological masterpiece that can slice through the sky like lightning, faster than any plane ever made, shrinking the distance between continents. This is the Oscillating Detonation Engine, ODE, the pioneering flame that propels China into the new era of hypersonic technology. ODE is not just a technical marvel, but also a symbol of ambition to conquer space and time. What makes ODE technology so extraordinary? How does an engine like this put China ahead of other superpowers in the hypersonic race? Join Top 10 Discoveries official as we explore China's journey with ODE, a technological breakthrough that's leaving the world stunned. The hypersonic technology race is shaping the future of aviation, and China has just made a breakthrough that demands the world's attention. In December 2020, Chinese scientists revealed the Oscillating Detonation Engine, ODE, achieving an astonishing speed of 12,276 miles per hour, equivalent to Mach 16, 16 times the speed of sound. While the US is still stuck at the Mach 9.8 record with the X-43A test aircraft in 2004, and Russia reaches Mach 8 to 9 with its Zircon missile, China's ODE has far surpassed these milestones, placing the country at the forefront of the hypersonic field. The birth of ODE is closely tied to China's impressive journey of overcoming challenges. In the 2000s, US technology sanctions severed the country's access to Western advancements, from jet engines to cutting-edge aviation systems. Facing these challenges, China chose self-reliance, investing billions of dollars into domestic research. Institutions such as the Chinese Academy of Sciences, CAS, and the China Academy of Launch Vehicle Technology, CALT, became centers of innovation, gathering thousands of outstanding engineers and scientists. ODE is the result of this investment, an engine that's not only faster, but also more efficient, using conventional aviation kerosene fuel rather than the expensive hydrogen-oxygen used in US projects. This is a revolutionary step, bringing China closer to realizing the dream of hypersonic aviation. ODE is not just a technical marvel, it's also a symbol of great ambition. With a speed of 12,276 miles per hour, it opens up the possibility of transforming the way we travel and explore space. This success didn't come by chance. It is the result of a long-term strategy where China turned barriers into opportunities to take the lead. Decades ago, the country depended on engine technology from Russia and the West. Now with ODE, China has not only caught up but surpassed, setting a new standard for global aviation. What makes China's ODE engine a technological marvel? The answer lies in its revolutionary operating mechanism, a leap forward from traditional engines. Unlike conventional jet engines or the US scramjet, which struggles with flameout at high speeds, ODE uses tilted shock waves to create self-sustaining explosions known as detonation diamonds. These explosions occur 1,000 times faster than the combustion process in US scramjet engines, like the X-51A, which only reaches speeds of 3,806 miles per hour. With thermal efficiency up to 80%, ODE far outperforms engines like the J8515 used in the US XB-1 aircraft, which only achieves 20 to 30% efficiency and a maximum speed of 1,675 miles per hour, nearly 10 times slower. A standout feature of ODE is its sophisticated combustion chamber design. A tiny bump, just 0.2 inches, is placed on the chamber walls to trigger the ultra-fast explosions, much like flipping a switch for a powerful energy reaction chain. Combined with wing-shaped struts, this design helps disperse RP3 fuel, a standard aviation kerosene, effectively at the extreme temperature of 180 degrees Celsius, 6,380 degrees Fahrenheit. Unlike US projects that rely on expensive and difficult-to-handle hydrogen-oxygen fuel, ODE uses RP3 to reduce costs and increase practicality. The ODE combustion chamber is 85% smaller than a scramjet, significantly reducing weight and allowing the aircraft to fly farther and faster, an advantage that engineers at NASA are still striving to achieve. Imagine ODE as an F1 race car, but instead of burning gasoline, it uses ultra-fast explosions to reach speeds multiple times faster. The tilted detonation wave mechanism provides superior stability, addressing the flame-out issues that the US X-51A faces at Mach 5. ODE maintains stable detonations from Mach 6 to Mach 16, producing continuous and efficient thrust. This is made possible through intelligent design with optimized fuel flow from the wing-shaped struts and the precise detonation trigger bump. The result is an engine that is not only fast but also durable, ready for practical applications in the future. This technology marks a turning point. While it took the US decades to achieve Mach 5 with the X-51A, China has broken through this barrier with ODE, providing unmatched performance and versatility. ODE acts like a miniature reactor, where each explosion is carefully controlled to generate maximum thrust. With this design, China is not only redefining hypersonic technology, but also proving that it is leading the technological race, bringing a future where distance is no longer a limitation. Turning a technological idea into reality requires rigorous testing under real-world conditions, and China has proven its exceptional capabilities with the JF-12 wind tunnel, one of the most advanced aviation research facilities in the world. Measuring 548 feet long with a nozzle width of 8.2 feet, the JF-12 can replicate the harsh hypersonic environment, ranging from Mach 9 to Mach 30, with testing durations lasting 130 milliseconds, far surpassing NASA's X-6A wind tunnel, which only achieves 100 milliseconds. It was here that the Oscillating Detonation Engine, ODE, underwent rigorous testing, delivering results that have stunned scientists globally. From the milestone of reaching Mach 9 in just 50 milliseconds in December 2023 to the record-breaking Mach 16 with stable detonation waves lasting 2 seconds in February 2025, the JF-12 has proven that China not only has the ambition, but also the infrastructure to make the hypersonic dream a reality. The JF-12 wind tunnel is not only impressive in scale, but also in its cutting-edge technology. Equipped with advanced heat-resistant alloys and precise fuel injection systems, the JF-12 can simulate the extreme pressure and temperature conditions of hypersonic speeds. In the 2025 experiment, the ODE reached a peak pressure of 20 atmospheres at Mach 9, with detonation frequencies of up to 1,000 cycles per second, a figure that showcases the engine's ability to maintain fast, stable explosions, a feat that facilities like NASA's X-6A are yet to achieve. The state-of-the-art sensor systems and real-time data analysis technology allow Chinese engineers to optimize the ODE design during the testing process, ensuring that every test run delivers accurate and reliable results. What sets the JF-12 apart is China's long-term investment strategy. With an estimated aerospace budget of $50 billion from 2020 to 2025, China has turned the JF-12 into the world's leading hypersonic research center, surpassing U.S. facilities in its ability to simulate high-speed conditions over extended periods. While NASA has struggled with technical limitations at Mach 10, the JF-12 has helped the ODE reach Mach 16 with unprecedented stability. This wind tunnel is not only a testing ground, but also a symbol of large-scale investment, where thousands of engineers and scientists work day and night to position China at the forefront of the technological race. The results at JF-12 represent a pivotal moment for China, bringing it closer to deploying ODE in real-world applications. From maintaining stable detonation waves to testing engine durability under extreme conditions, these experiments have confirmed that ODE is not just a concept on paper, but a technology ready to reshape the future. With this infrastructure, China is not just competing, but actively reshaping the global aviation industry. China's ODE engine is not just a technological marvel, but also a key to unlocking unprecedented possibilities, from revolutionizing the way we travel to transforming space exploration. With a speed of 12,276 miles per hour, 16 times the speed of sound, ODE promises to revolutionize numerous fields, offering opportunities that current technologies, such as the Boeing 747 or Concorde engines, cannot match. From civil aviation to space exploration and advanced technology, ODE is painting a future where distance is no longer a barrier. In the field of civil aviation, ODE could make hypersonic flights a daily reality. Imagine this: a flight from New York to London, which currently takes 7 hours on a Boeing 747 at 575 miles per hour, could now be completed in just 45 minutes. Compared to the Concorde, which reached Mach 2 but was retired in 2003, ODE is 8 times faster and uses conventional kerosene fuel, significantly reducing operating costs. With ticket prices estimated at around $10,000 per flight, ODE opens the door to affordable hypersonic airlines, where you could fly from Los Angeles to Shanghai in just 32 minutes, as fast as watching a short episode. This is the progress that U.S. projects like Boom Supersonic are still striving to achieve. In the field of space exploration, ODE offers the potential to change how we explore the universe. With a speed of Mach 16, this engine could support reusable spacecraft, reducing the cost of satellite launches from $10 million to just $2 million per launch. Compared to U.S. expendable rocket systems like SpaceX's Falcon 9, ODE offers superior efficiency, paving the way for affordable space tourism and missions that explore further than ever before. China is turning into reality a future where we can book space tourism tickets at reasonable prices, or companies can deploy global satellite networks in just a few hours. ODE could also support hypersonic unmanned aerial vehicles, UAVs, enhancing reconnaissance and cargo transport capabilities. Compared to the U.S. Tomahawk missile, which reaches Mach 5, ODE is 3 times faster, enabling intercontinental cargo transport within an hour. For instance, a shipment from Beijing could reach New York as fast as a click of a button, or hypersonic UAVs could collect environmental and weather data at unprecedented speeds. These applications not only provide commercial benefits, but also support missions such as rescue operations or disaster monitoring, where speed is a matter of life and death. ODE is a testament to China's vision in shaping the future. From super-fast intercontinental flights to affordable space missions and advanced technologies, this engine is opening a new era. With these applications, China is not just dreaming, but actively building that future today. To create a breakthrough like the ODE engine, China has made a significant investment in domestic research, building a powerful technology ecosystem that has propelled the nation from a follower to the leader in the hypersonic race. With an estimated $50 billion aviation research budget from 2020 to 2025, China has outpaced the U.S., which allocated about $30 billion to the same field from 2015 to 2025. This massive funding is not just a number, it stands as a testament to China's determination to shape the future of aviation, with ODE symbolizing their relentless innovation. At the heart of this strategy is the close collaboration between leading research organizations such as the Chinese Academy of Sciences, CAS, the China Academy of Launch Vehicle Technology, CALT, and Northwestern Polytechnic University. More than 10,000 engineers and scientists working at these facilities have created an innovation ecosystem where ideas are turned into reality at an astonishing pace. From 2020 to 2024, China registered over 5,000 patents related to hypersonic technology, double the number of patents filed by the U.S. in the same period. Compared to projects like the US X-51A, which faced delays due to technical issues and costs, China has accelerated its progress thanks to its focused resource allocation and strategic vision. A key factor in China's success is the application of artificial intelligence, AI, in research. AI is used to simulate thousands of design scenarios for ODE, from optimizing fuel flow to improving engine structure, helping reduce the development time from several years to just a few months. While the U.S. still relies on lengthy and costly testing processes, China has built a domestic research network that allows it to control the entire process from ideation to production. This not only speeds up development, but also allows ODE to use conventional kerosene fuel rather than the expensive hydrogen-oxygen fuel used in NASA's projects, giving it a significant economic advantage. China's strategy also lies in its ability to learn and adapt. In the 1980s, the country was dependent on Russian engines and Western technology. However, through continuous investment, China has built a self-reliant research system, from modern laboratories to a well-trained engineering workforce. This system not only produced ODE, but also laid the foundation for future advancements in hypersonic technology. Unlike the US, where defense contractors like Lockheed Martin often work independently, China has created a model of close collaboration between academia, government, and business, ensuring that every step is aimed toward a common goal. The success of ODE is proof of the power of this investment strategy. From a nation once limited by technological barriers, China is now setting new standards for the global aviation industry. We can witness an innovation ecosystem where thousands of brilliant minds work together to turn dreams into reality. This is the formula that has propelled China to the forefront of the hypersonic technology race. The ODE engine marks a technological leap that is opening up new possibilities for a new era in aviation and space exploration. With the goal of launching commercial hypersonic flights by 2030, China is painting a future where the distance between continents becomes insignificant and space is no longer a distant dream. China aims to have commercial hypersonic aircraft in operation before 2030, with prototypes expected to take their first test flights as early as the end of 2025. These aircraft will not only be faster, but also more efficient, offering an unprecedented travel experience. Unlike US projects like Boom Supersonic, which are still struggling with slower engines, China is betting on ODE to lead the way, turning global air routes into faster journeys and connecting the world more tightly than ever before. Beyond aviation, ODE opens the door to a new space age. China is aiming to make space tourism an experience accessible to everyone, with reusable spacecraft supported by ODE. In the future, you could book a ticket to view Earth from the edge of space, or companies could deploy global satellite networks at far lower costs than today. Compared to traditional US rocket systems, which are expensive and complex, ODE offers simplicity and efficiency, promising to bring space closer to everyone. This is the vision China is pursuing, a world where space is no longer the playground of billionaires. To achieve these goals, China faces technical challenges, such as developing materials that can withstand extreme conditions and optimizing engine performance. However, with significant investment in artificial intelligence and advanced materials, China is gradually overcoming these barriers, making ODE a feasible solution for the future. Leading laboratories at Northwestern Polytechnic University and other research organizations are working tirelessly to ensure that ODE is not just an idea, but a reality that can be implemented in the next decade. China's vision goes beyond just technology. It's about reshaping how the world operates. With ODE, China is positioning itself to lead the hypersonic aviation industry, challenging the dominance of powers like the US and Europe. While other nations are still developing slower technologies, China is already ahead, building a future where cities around the world are as closely connected as neighboring districts, and space becomes the next frontier for humanity. ODE is not just an engine, it's a symbol of continuous innovation, a nation daring to dream big and taking action to turn that dream into reality. The ODE engine is a testament to China's innovation power, from advanced laboratories to record-breaking experiments, paving the way for a new era of hypersonic aviation. It's not just a story of superior technology, but a vision of a world where the distance between continents disappears and space becomes humanity's next destination. With ODE, China is not only competing, but leading the way, setting new standards for global aviation. From smart investment strategies to significant technical advancements, this journey demonstrates a nation daring to think big and act decisively. So what do you think about a future with ODE technology? How do you believe this technology will change the way we live? And what strategies will other superpowers like the US adopt to catch up with China in the hypersonic race? Share your thoughts in the comments below. Don't forget to hit subscribe to stay updated with the latest analyses on technology, national strategies, and groundbreaking innovations that are shaping the future. Top 10 Discoveries Official will be back with untold stories, groundbreaking projects that challenge limits, and quiet revolutions with global impact. See you in the next video.